Let us now complete the week on image and video compression by just a very brief description of rank length coding. Rank length coding is very useful for normally when we want to encode binary images. So let's just draw a binary image, and that will help us to illustrate that. Let's assume we have an object here that has a certain gray value, and we only have two gray values. Let's say 100 in the background and 200 here. Okay, so we already have seen that if we do a smart representation of our image, we're going to be able to compress a lot. A smart representation means let's give to Huffman coding very nice distributions, very simple things, and hopefully less than we will get by encoding the whole image. So of course we could encode this image by saying many times 100 for the first row, same for the second row, and so on and so on. And imagine that this is, 10,000 by 10,000 image. So we're going to say 10,000 times 100, and we keep going. A smarter way is basically to do the following. To say, okay, let's just count how many times there is the value 100. Let's just count how many times there is the value 200, and let's count then after that how many times there is again the value 100. Basically, this count we don't have to do if we know that there is only one transition. So we count this, and let's say that there is basically 3,000 times the value 100. So instead of encoding 3,000 times 100, we encode this value. And then let's assume that there is 1,000 times, again, the value 200. So we put 3,000, then we put 1,000, and we're done. If we assume that there was only one object, one transition. If not, we can keep going. So by two numbers, we have encoded the whole row. And then we go to the next one, and we do the same. And this is called rank length coding because it basically encodes the run of equal numbers. We actually indirectly have seen that in JPEG already when we were in the transform domain of JPEG, an 8x8. I'm just drawing a part of this. And I explain to you that when everything becomes 0, there is a code that says end of block. That's basically encoding by basically one number everything that is going to happen to the end. And that's the basic idea of rank length coding. Again, very useful for images, in particular for basically geometric images, binary images, and indirectly was used in JPEG, but it's very popular here. And even if we have more than one object and another object here, we basically encode the runs. We say how many times there is 100, how many times 200, how many times again 100, how many times again 200, or any other value if needed. We encode the value and how many times it appears. And with that, we basically compress a lot these very, very simple images that otherwise will take us a very, very long codes to represent. And as before, we could just encode these numbers as they are, or we could plug them into Huffman coding and basically compress them even further. With this, we basically complete the week on image and video compression. And now we have images. Now we can receive images from every place. We can compress, we can store. Next week, we're going to start to process them. And what happens when basically our images are they don't look as nice as I wanted them to look. So that's what starts next week. See you next week. Thank you.